It says here that the graph shown is a logistic function of the form L over 1 plus AB to the negative x. So L, A, and B are just constants of the logistic equation that we'd like to find based on the graph that we see. And this is called logistic growth because it's sloped up here toward a maximum value. Now that maximum value for this graph appears to be around 12. This is where the plateau is leveling off. And the logistic function won't go beyond 12. It's often called an upper limit or like a carrying capacity. But that value of 12 has the letter L. It's the, upper limit of the logistic function. And so that right there answers the first one of what is the value of the upper limit of the function, 12. So when we write the function, it's going to be of the form L over 1 plus AB to the negative x. So we're going to have so far 12 over 1 plus AB to the negative x. Next, we're going to want to find the value of A, and this can be done if we look at the initial value of the function, which occurs here. This will be called f of 0, or the initial value. So f of 0 is clearly 4 here. And so you can imagine that if we plug in x equals 0 and y equals 4 here, we may be able to determine the a constant from that. So the x of 0 has to go in here, and the y of 4 has to go in for the value of f of x. So let's plug those things in. 4 equals 12 over 1 plus AB to the negative 0. But the thing about b to the 0, though, is that it's going to go away. It's going to become a 1. And so what we'll really end up with is just that 4 equals 12 over 1 plus a. So this is an equation that we could now solve for a. I'm going to multiply the 1 plus a to the other side with algebra, giving us this. Then I'll divide by 4. 1 plus a is 3. So we'll have that a is 2. At that point, our function becomes f of x equals 12 over 1 plus 2b to the negative x. And there's only one more constant to find, and that's the constant b. So it says here that we could find b if we knew just one other point that our logistic function touches. So just look in the graph, look for a point that it looks like your logistic function touches, let's say, the hatch mark intersection. Like right here, for example, that'd be an easy one to work with. This is the point 2, 8. So that's a combination of x and f of x that we could plug in additionally to discover what b is. So use the point 2, 8. So the 2 is going to go in for x, and the 8 will go in for the value of the logistic function. So 8 equals 12 over 1 plus 2b to the negative 2. And now we have to solve for b. Alright, so this is going to require some algebra here. we're going to want to multiply this entire denominator to the other side here. We'll put it there. Okay, you'd now want to divide by 8 on both sides. Subtract the 1 next. Next, we'll divide by 2. Then finally, we want to get rid of this negative 2 power, and we can do that by raising both sides to a power of our choice. And so the question is, like, what exponent should I raise it to in order to cancel a negative 2 power? So a while back there was this rule that if you have some base such as a raised to a power and then that was raised to another power, it could be simplified into the same base but raised to the product of the 2 powers. So we want to think about, like, what could we raise this to? We've got b to the power of negative 2. We want to raise it to a power of our choice in order to get an exponent of 1. And so the answer here is the reciprocal of the negative 2. Negative 2 times negative 1/2 would make 1. And so that's actually the exponent that I want to raise both sides to. And we can use a calculator to find this answer. It's 2. So that allows us to give a final answer for our function. Our function is 12 over 1 plus 2 times 2 to the negative x. Now, that's kind of the hard way of doing it. There's an easier way. An easier way would be to use regression, such as we could do on Desmos.com. So on Desmos.com, we would want to create a scatter plot that mimics the graph that we see. So click plus to add a table, and then start to put in some points that your logistic function goes through, such as 0, 4. That was the initial value right here. I also see that my logistic function goes through 2, 8. Now that is not going to be enough to do the regression because there's many logistic functions that could go through those 2 points. Like, you need more than just 2 points in order to do the regression. So we'd like to look around and see if we could find any other information that could help us. Like right here, it looks like there's another point that the logistic function goes through 1, 6. So that could be helpful. Put that in as well. We can start to do the logistic regression if we type in the formula for it. So type in y1 tilde and then just copy the general logistic equation, and you have to, put 1s on your x's and y's. And it looks like those 3 points, they were enough to complete the logistic regression. But I'll bet if we didn't have this point, yeah, it looks like with just these 2 points, it's really not doing it correctly. You can see it made a different graph there, so that's not good. That's not what you want. But when we do put in the 3 points, that's enough to get the correct graph. You could have, like, if you didn't have enough information, you could always put in that you know that the upper limit is 12. That would help eliminate one of the unknown constants. And then it'll give you the A and the B.